Hello. Today I'm continuing my series on using as many Redis features as I can from the Java platform. This time I'm looking at PubSub. If that's something that interests you, then watch along. I'm not attempting to build any kind of a YouTube following because this sort of stuff is pretty niche, but I would like to get better at making useful videos. So if you want to give me any positive or negative feedback or suggestions, I'd be grateful for your ideas and experience and any tips you can give me. So please, let's jump in. All right, so what do we want to achieve? Now, PubSub is a feature within Redis that means publish subscribe. It means that you can have a service publishing events to some kind of queue, and then you can have other services that subscribe to that queue and will listen to the events. Now, the advantage for this in enterprise architecture is that the publisher doesn't need to know who's consuming the events, and so it's very easy to add additional subscribers to that queue or that topic, and that makes for a very flexible, decoupled architecture. So it's something that we want to be aware of, and we want to deploy in appropriate cases. Now, Redis does offer this PubSub feature, and so let's test it out. So here's a diagram of what I want to achieve. We should have two instances of our Spring Boot service running in Docker along with our Redis cache. Instance 1 will be running on port 8080 and instance 2 on port 9090. I want to open two browser tabs, one which will be sending messages to instance 1 and the other will be sending messages to instance 2. Instance 1, for example, will publish a message to a channel in Redis, and instance 2 will subscribe to that channel. Instance 2 will then receive the message and send the message to the browser over an SSE channel, server-side events channel. Okay, so I think the objective is clear. Let's see what steps we need to take to accomplish it. Okay, this is my to-do list. So from the previous episode that I published on Redis caching, we already have an application framework which handles connection to the Redis instance, and so we can reuse that code. The next step for me will be to Dockerize the application because I want to have two instances running and I want to set up a little network where my instances are talking to Redis. It will be very convenient if I can Dockerize them first so that afterwards I can run this little architecture inside Docker Compose. So that's my step after that. Docker Compose lets me declaratively specify the architecture I want, how many instances of what kind of services, give myself some configuration, specify the dependencies between those services, and it's generally a good time for testing out architectural structures. So then within the code itself, we need to create the code that connects to Redis. And I'm going to create in the Spring Boot world a PubSub service. So by service, I mean a class that's annotated with the service annotation. So this will be responsible for connecting to Redis and offering the publish and subscribe functions to the rest of the application. And then I need to create a controller. That's a class annotated with controller or REST controller annotation for sending and receiving messages, which will utilize the features of the PubSub service created in the previous step. And then we'll need a user interface to enter messages and receive messages. And we'll create a bidirectional user interface so that if we go back to the previous step, both of these instances can send and receive messages, even though I've got it marked as one direction there. We'll have it so that they both can send and receive. Okay, so let's dive in. So the first step, other than having the application itself, was to Dockerize the application, and so I previously did a video which I'll link somewhere on three approaches to Dockerizing a Spring Boot application. And in this case, I'm going to use the code that I created for that, and use the third approach, which is to use the Gradle Jib plugin, which is a convenient way for making an efficient Docker image from a Spring Boot project. So let's take a look at the configuration here. So let's take a look at the configuration in my Gradle build. So for Dockerizing Spring Boot application, I've simply added the Gradle Jib plugin. Then I've added some Jib configuration, which uses Eclipse Temurin version 21 as its base image. The image that we're going to create is going to be called Mount on Tech Java Redis Demo Jib. Then there's some container configuration, so the flags that will be passed to the JVM, the entry point main class, the port we're going to be opening, and all this defines how and the format of the image. And all this is going to define how we're going to build the image. So if I go ahead and run Gradle build, Gradle wrapper build, then that'll go ahead and create the image. Whilst that's building, which will take a minute or two, let's move on to the next step, and we're going to look at running the architecture inside Docker Compose. So currently we are using Docker Compose at the moment to just simply run Redis in a convenient way. But we can do quite a lot more than that. And so what we're going to do after we've built this image, we're going to add two more services using this image, and those services will be run and depend on this Redis service. Let's first check that we have our image built. So this is the image that we've just built, and we can use this and run it within the Docker Compose environment. Go ahead and do that. So what I've done here is to add two additional services, so app1 and app2, and they use the image that we just created below. And the first one, app1, exposes its internal port 8080 to my computer's port 8080. And the second one, app2, exposes its internal port 8080 to my computer's port 9090. I've begun to set up some environment variables and for storing the password, the address of the Redis host and port and so forth. But I'm not going to continue along with that right now. We're not building something ready for production. We're just showing the principle. So I'll move right on and just run this. One other thing I should point out, though, is that since this is running within its own network, this cache becomes the host name of the Redis instance. And so, whereas previously here I had localhost, I had host as localhost, now I have host as cache. And this host will be looked up within the internal DNS system for Docker Compose and will be resolved to the cache instance that we have here. Okay, let me run it. Docker Compose up. Okay, we can see that the two Spring Boot instances have started, and the cache has started as well. Okay, so we now need to write the code that connects the Java applications to Redis and subscribes to events. And so let's move on and do that. But at this point, there are 0 connections, 0 clients to Redis because we don't have any connections set up. I'll stop this with a Control C, and we'll move on to our next step. So we're going to create the PubSub service. So currently, we've already created this Redis connection pool service when we were testing out Redis's caching features. And so we already have features for setting getting values within the cache and checking whether something exists. But we want to move on and add some subscribe features. I'll just tidy this up a little bit. Okay, so we've added 2 additional methods to this this class. Also renamed it, or also added an interface to extract out its public interface, and I'll go into that in a second. But the first method that we use will be subscribe. So we're using the Redis library for Java called Redis, and we've already got a mechanism for getting hold of the Redis client, and so the thing we need to do is call Redis subscribe and pass it a new Redis PubSub listener. Now, within this listener, it defines a number of different events that we can listen to, but really we're only interested in the on message, and so we're overriding on message. All of the other ones are just got empty implementations, and so on message will be called with the channel and message string when we subscribe to the channel name. So we're calling Redis subscribe with a listener instance and a channel name. And subsequently, our listener will be called, the on message method on our listener will be called each time this channel, which I called message channel originally, will be called each time this channel receives a message. Now, we want to make this subscription feature available to the rest of our application, and so there's any number of ways we could do it, but the way I've chosen to do it is to have our subscribe method here pass a consumer, a Java util function consumer, and so this way we can pass in a function reference, or we can pass in a lambda, and so when the on message is called by Redis, we'll just simply take this callback and pass this message on to that consumer. Okay, so that's the subscribe side of it, and then the publish side of it again is relatively straightforward. We take a string and we just call Redis publish with the channel name and the message. Okay, so let's see what's next on our list. Okay, so the structure we're aiming for is we want a PubSub controller. We want which is receiving HTTP requests from our browsers. It should use this Redis connection service to publish a message and subscribe to more messages. And the Redis connection service implementation uh, interacts over the wire to the Redis server. So what we're missing now is this PubSub controller and this connection. Now I have an SSE controller from a previous video on server-side events, and so I'm going to largely reuse this. I think I'll rename it because the focus of this video isn't on server-side events. So I can refer you to the SSE video somewhere. I'll give a link to the SSE video. And so I'll reuse this SSE controller and add in the additional features required to publish through Redis. Now we've got a this PubSub controller, which, as I said, is based on a previous controller I did for SSE. But the changes I've made to that are now I'm passing this Redis connection service reference into it, and I also have added an event listener for the Spring application ready event, so that when Spring has started, when Spring Boot has started up, it'll send out this event to any service or controller that's listening to it, and so we can do our initialization logic, which is subscribing this controller to the Redis connection pool implementation service. So for subscribe, this is subscribing from the client side to server sent events. So it's not related to Redis as such, but it does mean that we can do a live update to our user interface to push any messages that we've received from Redis. So send event receives the event from the client, and broadcast to client sends the events that we've received out to our web browsers. So our event listener, when we subscribe to the Redis events, Redis messages, we pass it this broadcast to clients as a consumer, and so this is responsible for sending those SSE events to the web browsers. We can compile this, make sure that nothing's broken whilst we move on to the next phase. Okay, so the next phase will be to create a user interface for the to be able to enter events, to be able to be forwarded to Redis and then picked up by other servers. So that compilation was successful. Now, from my previous SSE and Spring Boot video, I already created a simple user interface for testing server sent events. But I do want to add in a little bit of an upgrade here because at the moment it's not so easy to see the difference between the two servers we're talking to. So I'm going to just change a bit of the text on this screen, add the IP, the port number, add the port number so that we can be clear which browser tab is connecting to which service. So updating the title with a port number there, and everything else stays roughly the same apart from a few bits of text. So let's build and run this and see it in action. Okay, so we're running the Docker Compose, and you can see that the cache has started up. We can see application 1 and application 2 have started up. And then we can also see here that cache is reporting that 2 clients have connected to it. So that's a good place to be in. So let's open Chrome. We can open the first service on port 8080. And the second service on port 9090. And if I type in a message, hello 1 from server 1, nothing happens because because I made this so that you have to press subscribe first. So hello 1. Okay, and we can see here that there's in app 1 we have message received hello 1 to broadcast in the controller, and then app 2 we have received callback with message hello 1, and then in app 1 we have publishing message to Redis hello 1. I think this is out of sequence, but you can't blame it. Then in app 2 we're sending an SSE event to one SSE client, so that's over here. And then in app 1 received callback from Redis, so the message is going to Redis from app 1 and then is being sent back to app 1 and app 2 from Redis, and then app 1 is so that's when when app 1 over here is receiving the callback from Redis with message hello 1, and then app 2 is sending its SSE event over here. App 1 is sending its SSE event over to this browser. And then we're over. Okay, so let's do this again. Hello 1.2. Hello 1.2. And over here, if I do hello 2.1 and hello 2.2, we can see it's bidirectional. Okay, so let's look and see if we've achieved our goals. I think the demonstration just now shows that we've got 2 processes, each one running on a different port. They're both publishing and both subscribing to events through Redis, and both pushing those events to browsers that have connected to SSE connections. Okay, so I hope that's useful to understand the basic interaction with the publish and subscribe for Redis. The key code out of all of this is this part here, which is Redis publish, and this simply sends a publish message across the wire to Redis. We can look at the maybe look at the wire protocol on another day. And the other key part is the subscribe. Now, behind the scenes, obviously, I've written a lot of this code beforehand. So uh, there were, yeah, so I've written a lot of this code beforehand. In fact, my initial idea was to do the entire checklist um, in one video, including Dockerizing the application. But it turned out that Dockerizing the application deserved its own video, and SSE events deserved their own video as well. And even on setting up this service, there are various little issues to resolve, which would have broken the flow of things more than it has at the moment. So, but I will give a couple of tips. One thing that I think is very key in certainly in Spring Boot development, but more generally in all software development, is that you want a way to test your application whilst it's being built. So you want a self-testing code base. Now, I've not gone to the trouble of writing a load of unit tests for this, but a Spring Boot from the Spring Boot Initializer project does come with a simple integration test. And the advantage of this integration test is it will run your code within a Spring Boot context and will wire it up and send all the startup events and so forth. And so this can be a real lifesaver because following events in Spring um, after you've made an error can be quite time consuming if you're certainly if you're new to it. And so my advice would always be to keep your um, application compiling, but also having the integration test run every time you build it, and integration test run and pass, because it's the easiest way to discover when you've made a mistake. So I had some issue here where uh, when I was building, there was the service was being created, and it was trying to connect to Redis as it was um, uh, as it was running tests. And the reason for this was because I was I was trying to subscribe um, to the messages on a after initialization event within the controller, and so this was and because I didn't have Redis running in unit testing or in the compile environment, I was getting a network error, and so I was able to resolve that issue faster because I noticed the tests were failing, and by diving in and working out why the tests were failing, it was a lot easier to note that I was connecting to the Redis service in the wrong place. So always worth keeping an eye on your tests. Always worth ensuring that they pass. And in production work, professional work, you should be writing a unit test for every feature that you develop. But for time's sake, I'm not doing that entirely here. Okay, I hope this was useful to somebody. It's certainly been fun for me. Um, so if there's any thoughts or advice that you happen to have on this, anything else that you would like me to cover, I've got other topics on Redis that I am going to do, but also other common tools in the future. But if there's anything particularly that you'd like to learn about with me, then just drop a comment, and if it uh, if it takes my imagination, then I'll be happy to do a video on it. So thank you for your time.